morning, friends. Just we discussed about the half-wave rectification. That means the PN junction diode is used as a half-wave rectifier. In half-wave rectification, we only get the output voltage across the load resistance during the positive half cycle of input AC signal. During the negative half cycle of AC signal, no voltage obtained across the load resistance. Because the PN junction diode is in reverse bias during negative half cycle. So in short, when the PN junction diode is in forward bias, only the current flowing through the diode and also through the load resistance, we obtain the output voltage across the load. During the negative half cycle, PN junction diode comes into the reverse bias, no current flowing through the diode and no voltage obtained across the load. So how we obtain the output voltage across the load resistance during the both cycle, positive half cycle and negative half cycle of AC signal? For that purpose, we require the two PN junction diode and special type of the transformer is required which have the center depth. So today we are going to discuss about the full wave rectifier. So question is same as the half wave rectification. Explain the use of junction diode as a full wave rectifier. So here the circuit diagram of the full wave rectifier is shown in the figure. Here the two diodes D1 and D2 are taken. There is the transformer with the center depth. Okay. So primary coil of a transformer is connected with the AC supply, while the both ends of a secondary coil are connected with P sides of a PN junction diode, and N side of both diodes are connected with each other, and then it is connected in series with load resistance and center depth. Thus, in full wave rectifier, one transformer, two PN junction diode and one load resistance is required. Or full wave rectifier circuit is made of a transformer, two PN junction diode and a load resistance RL. Clear this? Okay. Now answer this question is that explain the use of junction diode as a full wave rectifier. The full wave rectifier is made of a transformer, two diodes D1 and D2 and a load resistance RL. The primary coil of a transformer is connected with the AC supply. That is the primary coil connected with the AC supply. While there is the secondary coil, both ends of a secondary coil connected with P side of two PN junction diodes. While the N side of both diodes connected with each other, and then it is connected in series with load resistance and center tap of the secondary coil. That is our circuit diagram. So how it works? So each diode works only during the half of the full cycle of AC simultaneously. So this both diode only works during the half cycle of AC signal simultaneously. That means when the diode D1 is in forward bias, at the same time diode D2 is in reverse bias. And when the diode D2 is in forward bias, at the same time diode D1 is in reverse bias. Right? That means that simultaneously the both diodes are working. As a result, the current is flowing. Suppose the diode D1 is in forward bias. So current is flowing through the D1, then load resistance RL, then center tap, again enter to the diode D1. This. Now, when the diode D1 is in reverse bias, diode D2 is in forward bias. At that time, diode D2 is working. And current flows through the diode D2, load resistance RL and center tap like this. So thus, during the both half cycle, the current flows through the low resistance aisle and we get the output voltage across the load resistance during complete AC signal or the AC cycle. Now the working of this circuit. Each diode works only during the half of the full cycle of AC simultaneously. And so during the full cycle of AC, between the two ends of load resistance aisle, the current obtained in the one direction from X to Y. So it is called the rectifier current. Again, each diode works only during half of the full cycle of AC simultaneously. And so during the full cycle of AC, between two ends of the load resistance aisle, the current obtained in one direction, that means from X to Y direction. So it is called the rectifier current. Now, during the AC cycle, when the A becomes the positive, B becomes negative, that means the positive half cycle is applied here. So A becomes positive, B becomes negative with respect to the center tap. Therefore, diode D1 is in forward bias. Therefore, the current flows through the D1 and load resistance aisle in the direction X to Y. While the diode D2 is in reverse bias, no current flows through the diode D2. Again, during the AC cycle, when A becomes positive and B becomes negative with respect to center tap, the diode D1 is in forward bias and current flows through the D1 and low resistance aisle in the direction X to Y. While the diode D2 is in this condition, that is in reverse bias, so no any current flow through D2. Again, during the AC cycle, that means the positive half cycle, A becomes positive, B becomes negative with respect to center tap. Thus, the diode D1 is in forward bias. So the current flows through the D1 and low resistance aisle in the direction X to Y. This X to Y. This direction the current is flowing. While diode D2 is in reverse bias, no any current flows through the diode D2. Now next, during the other half cycle, that means the negative half cycle, A becomes the negative, B becomes positive with respect to the center tap. Diode D1 is in reverse bias. No current flows through the diode D1. While the diode D2 is in forward bias, therefore current flows through the D2 and low resistance aisle in the direction X to Y. X to Y. Therefore the current direction of the flow of current is diode D2, low resistance, center tap, again diode D2, low resistance, center tap, this way. When the diode D2 is in forward bias. Next, another positive half cycle is applied. A again becomes positive, B becomes negative with respect to center tap. Diode D1 is in forward bias, diode D2 is in reverse bias. Current flows to the D1 and low resistance aisle, no current flowing to the D2. Next, coming negative half cycle, A becomes negative, B becomes positive with respect to center tap. D1 is in reverse bias, D2 is in forward bias. Now the current flowing through the D2 and low resistance aisle. Thus, both diode works only during the half cycle of full AC cycle simultaneously. And continuous load resistance, continuous current flowing through the load resistance RL. So there is the full wave rectifier. Again we discussed about what is the circuit. The full wave rectifier is made of a transformer, 2 p-n junction diode and a load resistance. A full wave rectifier is made of a transformer, 2 p-n junction diode and load resistance. That is the transformer. That is shown by the dashed line. The primary coil of a transformer is connected with the AC supply, while both ends of the secondary are connected with P side of p-n junction diode, while the N side of diode, both diode connected with each other and is connected inside with load resistance and center tap of a secondary. So that is the construction or the description of the figure. How the working? So each diode works only during half cycle of full cycle of AC simultaneously. One by one they are working. During the full cycle of AC signal, only during the half cycle the any one diode is work. The full cycle of AC between the two ends, and the current flowing to the two ends of load resistance iron, and which is called the rectified current. Here the both diode works only for the half cycle of full cycle of AC simultaneously, and the current flows between the two ends of the load resistance iron in one direction x to y, and it is known as the rectified current. Now during the AC cycle, when the A becomes positive, B becomes negative. So diode D1 is in forward bias and current flows through diode D1 and load resistance I in the direction x to y. X to y. That means the current is flowing in this direction in both cases. And diode D2 is in reverse bias, no current flows to the diode D2. During the other cycle of AC, when A becomes negative, B becomes positive. Diode D1 is in reverse bias, no current flows to the diode D1. But diode D2 is in forward bias, so the current flows to the diode D2 and also through the load resistance iron in direction x to y. Thus, during the both cycle of AC, the both diode works simultaneously and current flowing to the load resistance in one direction x to y. Clear this? And what is the output, or what are the applied voltage at point A and B is shown. At point A, when the positive half cycle is applied, at the same time at B point the negative half cycle is applied. Therefore diode D2 is in reverse bias, diode D1 is in forward bias. When at point A negative half cycle entered, at the same time at point B becomes positive, that means the positive half cycle. Therefore diode D2 is in forward bias, D1 is in reverse bias. Next, incoming the positive half cycle, so at B and negative half cycle is applied. So diode D1 is in forward bias, here diode D2 is in reverse bias. So last graph is the output across the load resistance iron. During the both cycle, positive, negative, positive, negative. During the positive half cycle at point A, the diode D1 is in forward bias, output current is obtained, or the voltage is obtained across the load resistance iron. During the negative half cycle, diode D2 is active, that means is in forward bias, we obtain the output voltage across the load resistance. So thus during both cycle or the full cycle of the AC, we obtain the output voltage across the load resistance. Clear? So that is the graph on the waveform of the voltage at point A and B, and also voltage across the load resistance RL. Okay, just we discuss about that. When the negative half cycle is applied at the point A, so point A becomes the negative and point B becomes the negative. That means during the other half cycle, A becomes the negative and B becomes the positive. So diode D1 is in reverse bias and diode D2 is in forward bias. Thus, the current flow through the B becomes the positive, diode D1 is in reverse bias, so no current flow through the diode D1. But diode D2 is in forward bias, so current flows through the diode D2. And load resistance R in the direction x to y. It means when the negative half cycle of the AC signal is applied, so A becomes the negative, B becomes the positive. So diode D1 is in reverse bias, so no current flowing through the diode D1. But B is positive, therefore diode D2 is in forward bias. Therefore, current flowing through the diode D2 and load resistance R in the direction x to y. Hence, current flow through both diodes simultaneously during the AC cycle and current flow through the load resistance R in one direction. So, DC voltage across the load resistance R is obtained. During the positive half cycle, D1 is in forward bias, D2 is in reverse bias. Therefore, current flowing through the D1 and load resistance R. During the negative half cycle, diode D1 is in reverse bias, D2 is in forward bias, current flowing through the D2 and load resistance R. Thus, during the both cycle of AC, current flows to the both diodes simultaneously during AC cycle, and current flows to the load resistance R in one direction. So, DC voltage across the load resistance is obtained. The input of the both diode and output of the waveform across the load resistance R is shown in figure B. Just we discussed it. The efficiency of the full wave rectifier is higher than the half wave rectifier. Efficiency of the full wave rectifier is more than the efficiency of half wave rectifier. Therefore, full wave rectifier is widely used. Because in half wave rectification, only during the positive half cycle we obtain the output. During the negative half cycle, the voltage is zero. Output voltage is zero. While in full wave rectifier, during both cycle, or the both positive and negative half cycle, we obtain the continuous voltage across the load resistance RL. Therefore, efficiency of the full wave rectifier is higher than efficiency of half wave rectifier. So, hence we discussed about the half wave rectification and full wave rectification. So, sometimes the question arises is that due to the full wave or the half wave rectification, whatever the voltage obtained across the load resistance is pure DC. So this time the question arises. No. Because in the gap of both half wave rectification and full wave rectification, we obtain the DC voltage in that form. Sine. Well, the DC voltage is the constant voltage with time. That means for DC voltage does not varies with time, while the AC voltage is varies with time. Therefore, what is the output voltage of a rectifier circuit? But the rectified voltage is not pure DC. Some part of the AC is also included in this output voltage. And whatever the component of the AC is present in rectified voltage, that is known as the ripple. It is necessary to remove this ripple to obtain the pure DC voltage. To remove this type of the component of the AC from the rectified voltage, the different type of the filter circuits are used. Widely used filter circuit is capacitor filter. Other filter circuits are inductor filter, LC circuit, and also the pi filter. But these filters are not used in common purpose. In common purpose, that means in power supply, in our TV and also AC, we are using the capacitor filter. Now we are going to discuss about the filter circuit. Right? Okay. Again, question is that describe the simple filter circuit to obtain smooth rectified voltage from junction diode rectifier. How we obtain the pure DC voltage or smooth rectified voltage from junction diode rectifier? The rectified voltage is in the form of pulses of the shape of half sinusoid. It does not have the steady value. Just we discussed about that in full wave and half wave rectifier. The output rectified voltage is not constant with time, that is varies with time. From 0 to maximum, again becomes 0, again from 0 to maximum, again 0. So this is the varies with time, that is not a pure DC voltage. Here AC component is also present in this output voltage. Therefore, the rectified voltage is in the form of the pulses of the shape of half sinusoid. It does not have the steady value. To get a steady DC output from pulsating voltage, a capacitor is connected in parallel to the load resistance. A capacitor is connected in parallel to the load resistance, or an inductor is connected in series to the load resistance. Generally, the capacitor and inductor are used to obtain the pure DC output from this type of the rectified output. Since the additional circuit filter the AC ripple and give a pure DC voltage. So this additional circuit filter the AC ripple and give a pure DC voltage. So they are called the filters. By connecting the capacitor parallel to the load resistance, or instead of the capacitor, inductor is connected in series with the load resistance. The AC ripple are filtered from the rectified voltage, and we obtain the pure DC voltage. So this type of the circuit or this component are known as the filters. Yeah. Now, how the capacitor, here we discuss about the capacitor filter, how the capacitor remove the AC ripple from the rectified voltage and we obtain the pure DC voltage. When the voltage across the capacitor is rising, so here there is a voltage is the sinusoid DC. When the voltage is rising, the capacitor gets charged. If there is a no load, no extra load, it remains the charge. When there is a load, it gets the discharge to a load voltage to a load. Voltage across it begin to fall. So what's happening? When the voltage, rectified voltage is increases, so capacitor is rising, but the voltage across the capacitor is rising. That means the capacitor is charged. It gets the charge. If there is no external load, if no external load is connected, so what's happened? It remains charged. When there is a load, it gets the discharge to a load. When the load is connected, so capacitor now start to discharge to the load. Right? So voltage across it is begin to fall. So what are the maximum voltage across the capacitor? Now it's going to decreases or going to fall. In next half cycle of the rectified output, it again gets charged as shown in the figure. So what it says there? So there is the input AC signal. What is the output with C filter? So when the AC voltage or the rectified voltage is increases, so capacitor gets charged and reaches to the maximum voltage. In absence of the external load, it not discharged, so its voltage is remain constant. When the external load is connected, it starts the discharge and fall. Its voltage is decreased. Right? And also, in next half cycle, the voltage of the capacitor is again going to increase and then again decrease, but again fall. The rate of fall of voltage across the C depends inversely to the product of the capacitor C and load resistance I. That is known as the time constant. The increase and decrease voltage of the capacitor, that is, depends on inversely depends on the product of capacitor and load resistance I, and that is known as the time constant. To make the time constant large, the value of the C is required also large. The output voltage is obtained by using the capacitor filter is near to the peak voltage of the rectified voltage. So this type of the filter widely used in power supply. Widely used in power supply. Again, what is the filter circuit? So our concept must be clear about that. What is the rectified voltage obtained in half wave and full wave rectifier? This voltage is not constant with time. The shape of this voltage is like this, half sinusoid. So that is the phase with time. Phase with time. Okay. To obtain the constant voltage, the two types of the component are used as a filter. So one is the capacitor, second is the inductor. So answer to this question is that the rectified voltage is in the form of pulses of the shape of half sinusoid. It does not have the steady value. To get the steady DC output from pulsating voltage, the capacitor is connected in parallel with load resistance R, or an inductor is connected in series to the load resistance R. That means the inductor and capacitor are used as a filter. When we are using the capacitor, it must be connected in parallel to the load resistance R. And when we are using the inductor as a filter, so it must be connected in series with the load resistance R. Since the resistance circuit filter, the AC equal and so a resistance circuit filter the AC equal and give a pure DC voltage. So they are called the filters. They are called the filters. How the capacitor works as a filter? So when the voltage across the capacitor is rising, so capacitor gets charged, and if there is no external load, so it remains charged. When there is a load, it gets discharged to a load. Thus the voltage across it begin to fall. Output it again in next half cycle of rectified output, it again gets charged as shown in the figure. So when the rectified output in form of pulses are incident on or connected with the capacitor, it gets charged, discharged, charged, discharged, this way. The rate of fall of voltage on capacitor depends inversely to the product of capacitor and value of load resistance, and that is known as the time constant. To make the time constant large, the C required also large. That means the value of the C is also required large. The output voltage is obtained by using the capacitor filter is near to the peak value of the rectified voltage. So here the output voltage is obtained almost constant nearly to the peak value of rectified voltage. So this type of the filter widely used in power supply. So there is the filter circuit.